Mars still has its water, every drop of it locked inside the rock, chemically fused to the ground, and the planet has been drinking itself dry for 4 billion years. Not evaporated, not stolen by solar wind, not frozen at the poles waiting to thaw. Consumed, absorbed into the stone beneath its own feet, the way a sponge absorbs water and then hardens into a brick you can never squeeze dry again. 4 billion years ago, Mars had oceans, real ones, deep enough to drown skyscrapers. The northern hemisphere was covered in water, reaching hundreds of meters deep across a third of the entire planet's surface. That is not a poetic estimate. That is what the geology says, what the orbital data confirms, what the rocks from Mars, sitting in labs right now, still carry inside them as chemical evidence. Mars had more water than Antarctica, more than the Arctic Ocean, a world that looked from space like it might be worth visiting. And then the ground ate it. Most people assume they know what happened. You've seen it in every documentary, every Mars movie, every artist's rendering of a dying world. The atmosphere strips away, the magnetic field collapses, the oceans thin out under a weakening sun. The water molecules break apart and drift into space. The story of a puddle drying up, but planetary scale. It feels right. It matches what we know about thin Martian air. But that story accounts for maybe a fraction of what actually disappeared. The rest, potentially between 30 and 99% of all water Mars ever had, never left the planet at all. It went down. When water meets certain rocks under pressure, the water doesn't just sit on top of them. It doesn't just seep through cracks. The water molecules fuse chemically with the rock's internal mineral structure, bonding so tightly that the water stops being liquid, stops being vapor, and becomes part of the stone itself. The rock changes. It becomes a new kind of mineral called a hydrated silicate or a clay, and that water is now permanently imprisoned inside it. You cannot heat it out. You cannot pressure it back to liquid. The chemistry runs in one direction, locks, and never reverses. Think of it like cement. Once concrete sets, you can pour water over it forever. It will never turn back into wet powder. Mars did this with its entire ocean. The ground was the cement, the ocean was the water, and the setting took a few 100 million years. The evidence for this isn't theoretical. NASA rovers driving across the Martian surface have been finding clay minerals everywhere, the exact minerals that form when rock chemically absorbs water and locks it in. Orbiters scanning from above, instruments on missions like Mars Odyssey and Mars Express have mapped these hydrated minerals across enormous regions of the planet's crust. Scientists have analyzed actual pieces of Mars, meteorites knocked off the planet by ancient asteroid impacts and eventually landed on Earth. Those meteorites are packed with minerals that formed in the presence of water and absorbed it permanently. The rock is the proof. Mars drank its water, and we are holding the cups. Right now, underneath the Martian surface, not at the poles, not near any volcano, not anywhere accessible, there may still be liquid water. Seismic sensors from the inside lander, listening to Mars quakes the way a doctor presses a stethoscope to a chest, detected signals consistent with liquid water sitting 5 to 8 kilometers underground. 5 to 8 kilometers, that is 4 times the height of the tallest building ever constructed. Straight down, into rock. That water is not in a lake. It is not in an underground ocean with a ceiling you could swim to. It is soaked into porous rock, the way a sponge holds water, distributed through stone, surrounded by stone, part of stone. If you drilled down and reached it, you would find wet rock, not a pool. The water is there. It is also completely, permanently unreachable by anything living on the surface above it. And Mars made its second catastrophic mistake at the same time. On Earth, there is a system that keeps the planet warm even when the sun is not generous: volcanoes. Volcanoes constantly release carbon dioxide, the same gas that traps heat in a greenhouse, back into the atmosphere. The gas stays up, keeps the atmosphere thick, keeps the surface warm enough for liquid water. Without that constant volcanic replenishment, the carbon dioxide gets pulled out of the atmosphere and absorbed into rocks. The greenhouse weakens. Temperatures fall. Ice forms. And on early Mars, that is precisely what happened. But worse. Mars volcanism burned intensely for a short time and then simply stopped. By about 3.5 billion years ago, the volcanoes had gone quiet. The thin Martian atmosphere started getting pulled into rocks, same chemical absorption process that ate the water, and nothing was putting it back. No warm blanket, no recycling system. The planet's thermostat was broken, and the cold came permanently. Imagine a house with walls made of sponge. In the morning, you turn on the heat. The walls absorb it. You add more heat. The walls absorb that too. You turn up the furnace as high as it goes. Eventually, the walls are warm. But then the furnace breaks, and the walls begin slowly releasing all that stored warmth outward, not inward. The house cools. You cannot restart the furnace. You cannot squeeze the warmth back out of the walls. The house will never be warm again, not because the fuel is gone, but because the building itself consumed and locked away every BTU you gave it. That is Mars. The furnace was the volcanoes. The walls were the crust. The warmth was the water and the atmosphere. And the furnace broke around 3.5 billion years ago. The cruel precision of this process is in how it reinforced itself at every step. As water got absorbed into minerals, the atmosphere thinned. Less water vapor, less pressure, colder temperatures. Colder temperatures caused more water to freeze at the surface. Frozen water on the surface was in direct contact with rock and kept absorbing into it chemically. Less atmospheric water meant less ability to sustain any kind of greenhouse warmth, which meant colder nights, faster freezing, more absorption. The more the planet lost, the faster it lost the rest. By about 3 billion years ago, the surface was dry, not gradually hostile, definitively, permanently dry. The first dinosaurs would not appear on Earth for another 2 billion years after Mars had already consumed its last ocean. This number should stop you completely. Scientists estimate Mars may still have enough water locked underground to cover the entire planet's surface in an ocean between 700 and 900 meters deep. That is the water that is still there, trapped in rock kilometers below the surface, chemically sealed, unreachable. Mars did not lose its water. Mars still has it. It just buried it so thoroughly and locked it in so chemically that not a molecule of it will ever see sunlight again. The planet is not a desert because the water is gone. It is a desert because the water is imprisoned. What this tells us about Earth is the part that should keep you awake at night. Our planet is warm and wet because our volcanoes never stopped working and our tectonic plates never stopped moving. They constantly recycle carbon dioxide from rock back into the atmosphere. They keep the greenhouse going. They keep the water cycle alive. If our volcanoes went silent tomorrow, not gradually, not slowly, but simply stopped, the carbon dioxide would start getting pulled into rock. Temperatures would drop. Water would begin freezing and absorbing into minerals. The process would reinforce itself, exactly as it did on Mars. There would be no dramatic explosion, no asteroid, no invading darkness from space. The planet would simply start drinking itself, quietly, from below, the way it did next door 4 billion years ago, and the way the chemistry says it would work here too, because rocks do not care which planet they are on. They just do what the chemistry allows, and the chemistry, once it locks, does not negotiate.